Welcome back to the Southwest Climate Podcast, the niche podcast on the climate of the Southwest, the only one. Mikey, how you doing?
Good, Zach. I like niche.
Niche. This is our first edition of 2022.
2022. I think we started in 2011, so we doubled 11, made it to 22.
Yep. Been doing this a long time. Still waiting for that Spotify contract. Not holding my breath. But as always, this is like one of the highlights of my month. So as long as our parents listen to us, we'll keep doing it.
Again, I don't think my parents listen to this, Zach.
All right, Mike. Well, I'm excited. So got a lot to cover. Our last episode was before the holidays, mid-December. So we've got almost a month and a half to cover. Lots happened. Maybe some surprises, maybe not. I appreciate doing these on Friday because I'm usually in a good mood and thinking optimistically, but I'm curious to see, Mike, if it's a Friday mic or a Monday mic in some of the way that you talk about what we've seen in December and January. So give you a little bit of the outline. As usual, we'll do a little bit of a recap, try to talk a little bit about the synoptics, the dynamics that occurred. And, it's at the point of the winter, nearly about a third of the way through where, snowpack and what's been in the past weighs more heavily on the future. So we'll recap and talk a little bit about snowpack and stream flow, maybe a little drought, maybe sprinkle a little bit of drought in there. Follow that up with February and March expectations.
Sounds great, Zach. Those are all my favorite flavors of climate.
Fantastic. So December and January, Mike, kind of a tale of 2 months, if you ask me. We started this winter season, early winter season, kind of with the prolonged dry period. But, after coming out of the generational monsoon, we were still giddy. So we were resting on those monsoon laurels. Mid-December, we were hoping the winter would pick up. It was a La Niña. It is a La Niña. So obviously the odds are tilted a little bit toward a drier than average situation. And we were sort of following in those footsteps. And so a tale of 2 months is kind of what I'm thinking. December actually was fairly good for much of the West, aided in part by a number of sort of big atmospheric rivers that streamed into the West Coast. Like if you look at a percent of average precipitation map for the Western US, you can kind of see those, the really big events as they bisected California into Nevada and dropped quite a bit of rain and snow in Arizona and Nevada and the Western side of the Rocky Mountains. So much above average for December across the West until you get to the east of the Rockies in Colorado and in New Mexico. Then it turns dry. And then just thinking about rainfall, the last 30 days. So pretty much a little tail end of December, but all of the January so far, and we're talking about this on January 28th, but it's been dry. So just to sort of put this in a big picture, that December really kind of changed the story and for many of the stations, many of the areas across Southwest, and we're sort of like hovering close to average in terms of rainfall. Tucson is a little bit below average. I would say actually Tucson is not faring as well as other places. But if you look at Flagstaff, for example, it's right around average. Phoenix is a little bit below average. And then Albuquerque, to the drier side of things, is much below average. And Las Cruces to southern New Mexico is 75-80% of average. But that December was really key, I think, for us. And had we not had that, then the situation would be a little bit more dire in terms of drought going forward. So, Mike, why don't you take us through sort of the weather patterns of the last 2 months that sort of gave us that kind of wet December and into the drier part of January?
Yeah, so I think our podcast was in mid-December. So we met up and talked. There wasn't much had happened since the monsoon. We had some ups and downs in temperatures, and we were a little bit concerned about the La Niña event being present again for the second year in a row. And we're looking to last winter as, potentially an analog. You're like, are we going to do a repeat of last winter into this one? And just as we recorded the podcast, I think it started to rain, Zach. So possibly we can take some advantage and some credit of prompting the wet spell that followed after that.
Just out of curiosity, was that sound your rainfall sound? Like when that came on,
like my sound.
I was like, are you doing sound effects now?
It was actually, I'm sorry, I was getting chatted on another channel here. But basically what ended up happening was we started to have a series of troughs settle into the broad Western US in mid-December, and just had a really fantastic run of precipitation. And it brought above average precipitation, especially in the last, we're looking at like the 2 month or the 1 month standardized precipitation index. If you look at that for December proper, you see above average precipitation from the Pacific Northwest all the way through Southern California. It extends into Arizona, Utah, and the Intermountain West. And just like you said, it actually extends into Colorado, and it's like right at the Continental Divide is the break point. So everything on the western side of the Continental Divide did really quite well with this rally of precipitation that we saw from mid-December all the way through the end. And for Arizona proper, our kind of best run was right around the Christmas to New Year's holiday week there, where we ended up having a couple of rounds of heavy precipitation. Some were wetter than others, some were colder than others, and brought some snowpack. But all in all, that pushed most of the state to seeing above average precipitation for December. It was interesting. There was a real sharp gradient, though, as you went to far southeast Arizona, and this kind of extended into New Mexico as well. It just kind of trailed off. And so it kind of mapped onto the trough pattern where those storms were tracking. And we were just far enough to the west to kind of get the benefit of it. And you were further east, you didn't see as much precipitation out of those events.
Yeah, so I'm looking at just the Tucson International Airport just to add to that. And yeah, so from October 1 until early December, no rain. And then it basically there hasn't been a rain event since that January 1st, it looks like.
There was a small event in the middle of the month, and so if you want to, we can kind of take the story and walk it a little bit further down the road here. But that pattern, it was largely, so we call it zonal, meaning that we didn't have large waves across the continental US, but we had this sort of kind of even trough across the Western US that had a couple of storms that kind of came through in that zonal flow, gave us all that precipitation. And that really, January 1st was the end of that. So, and then January 2nd, we started to have a ridge of high pressure build in from the south. And that nudged its way up into much of the West as you got into kind of the middle part of the month. So really dried out across the West, and the temperatures went up. So we actually went a little bit above average there for a period. And then more recently, we've started to see the ridge of high pressure kind of retreat back to the East Pacific. And now you're starting to see these really strong cold events come down through the northern Great Plains and on the front range of the Rockies. And some of that now is sort of working its way, that cold dry air is working its way back into the Southwest, which has been some of our more recent wind events out of the East.
This ridge trough pattern, I mean, we talk about this quite a bit for both the monsoon season and the winter, but of course we're talking about different things, right? So I'm looking at these maps that show they sort of sketch out the position of the jet stream, more or less, which would be defined by the sort of leading edge, not the leading edge, but the crest in a trough. Sorry, yeah, the crest in a trough and the peak in a ridge. So that position of the ridge and trough is defining more or less the polar jet stream, correct?
Yeah. I think you could map the jet stream onto that. I think when you and I are talking about ridges and troughs, we're usually talking about it at this 500 millibar geopotential height, it's basically a way of trying to figure out in the atmosphere where a constant pressure level is across the entire globe, right? And so that pressure level is going to be higher or lower depending on the temperature in the column of air below it, right? And so that's going to give us an indication of if that column of air is higher at a higher height, it's under warmer conditions, which is going to be a ridge of high pressure. If it's unusually with respect to the long-term average at that spot, and lower if it's colder air, right? So the ridge is going to be that bumping to the north in the northern hemisphere of those warmer than average conditions. So it's a bump to the north. So it's kind of a rounding inflection to the North Pole. The trough is going to be the colder air underneath that. So it's going to be the opposite. And so it's going to be troughing with that colder air kind of pointing towards the equator. So when you talk about the jet stream is actually at a level higher than that, but still maps on to where these ridges and troughs are occurring. Like if you're looking on a weather map. Did I blow your mind?
No, I mean, there's like a three-dimensionality to this it's hard to talk about.
It's really hard to talk about on a podcast.
Because the position, the jet stream, the polar jet stream, right, is an important aspect to our winter weather because it's this area of higher winds. It has this sort of sinuous, wavy pattern that goes around the globe. And in our winter, and it's driven by, large scale changes in the thermal, like it's basically like the thermal gradients between the poles and the tropics that really generate both the latitudinal position and also it's sort of the waviness to it. So it's a thermal feature, global feature. And it's critical because it's kind of what pulls in our storms. It's further south to us in the winter. And so it's the thing that we pay more attention to. So it moves. So in the summer, it's further north, and we're actually more influenced by the subtropical jet. So there's a couple, at least in the northern hemisphere, the two main jet streams that are of consequences: the polar jet, which is 60 degrees north, more or less, and but it can change in position, but just in terms of a general position, and the subtropical jet, which is more like mid-latitudes, 30 degrees north. But because of the winter summer seasonality, those mean positions, those average positions are moving south in the winter and north in the summer. But that's a sort of all background. The position of that jet stream and its pattern is critical for us because it's what's helping to create the winter storms, right?
Yep. So storm tracks largely follow jet stream position. We started podcast prep several hours ago, and you brought up this idea of storm tracks and jet stream, and then we both pointed out or knew that ENSO, I'm just trying to give credit that we're kind of riffing on the latest ENSO blog from climate.gov, because there was a nice write-up on jet streams directly in there. And right in this write-up, they have like a one-line sentence here is like, why do jet streams exist? Because of two crucial ingredients, rotation and heating. And that's exactly what you just pointed out, right? Is that the jet stream emerges in response to thermal gradients that are sharpest at the surface and translate up into the atmosphere through these geopotential heights. And the fact that the Earth is rotating causes a deflection of basically the physics of trying to realize or smooth out this thermal gradient, right? So you get that. And so just to kind of to go a little deeper on what you're saying there too, is that in Northern Hemisphere winter, there's much, much colder air at the North Pole that extends further south to lower latitudes. So those temperature gradients also push further south. And that's why we're able to get into mid-latitude jet stream action at lower latitudes like the Southwest, and why it retreats to the north as you get further and further into spring into summer, because the whole Northern Hemisphere is heating up. And that cold air is retreating to the poles, and that's where the jet stream follows.
Right. And so when I was actually, it was funny thinking about the jet streams and then going to the Info blog and seeing that they had written about it. I was like, okay. Like,
yeah, right on. Yeah.
Yeah. But what I was thinking today is, if you look at the last 30 days and when rainfall stopped here for the most part, close to January 1st, and prior to that, that jet stream, that the sort of pattern was more favorable for precipitation. That is that it dove down more into our area, more southerly flow, more, as you said before, sort of meridional, north to south. And then as you get into more of January, we didn't have that favorable pattern. And so the precipitation sort of mapped right onto that jet stream pattern as well. So it's pretty consequential to us thinking about when we get our events and when we don't get our events. And then that sort of led me down the thought pattern. It's like, oh, well, that makes kind of sense why we have such high wintertime variability in terms of we get a storm maybe once every 2 weeks that brings rain, is because we're sort of on the southern margins of the jet stream. More time will be spent with that jet stream. We'll sort of track more to the north. And we were sort of working through this, Mike, and then you passed this paper from 2012. Maybe you could talk a little bit more about this. But what blew my mind was the average storm track pattern actually goes right over Arizona. Yeah,
it's pretty cool, isn't it?
So, I mean, in my mind, I was thinking, well, okay, that doesn't jive with the fact that we don't get a lot of rainfall in the winter, and it doesn't jive with the fact that, I don't have these numbers offhand, but that basically we're getting a couple storms. What do we get? An inch of rain here in Tucson in January, and maybe a little bit less of that in February and in March or something like that. But that's a couple events, maybe 3 events, one every 10 days or something like that. If we're lucky, maybe there's a 4th one, but it's not a lot of events. But yet the average storm track is sort of flowing over this overhead. And I guess I would have thought that it would have been further north. So then that raises the question of if that position is more favorable for storm tracks to be wafted in, why aren't we getting more rainfall?
I like this paper and have looked at it a couple of times over the years. It's Loreau and Horel. Horel. It's John Horel from University of Utah. But there's actually quite a few papers on storm track climatologies across the continental U.S. and the Western U.S. And they all kind of point to this really interesting thing, is that there's actually a high frequency of storm track convergence in basically low pressure systems. And low pressure systems, when they move through an area, they force ascent. So basically they lift air. And when you lift air, that's an important mechanism to lifting cool parcels of air and hopefully condense water in those parcels into clouds and precipitation. So that's, to your point about storm track, is that the development of lows and the sustaining of surface lows is really important and tied to jet stream position. So we actually have a storm track or a maximum over the Southwest. If you look at the climatology, and like you said, it's kind of surprising, right? Because it's dry generally, and we don't end up seeing frequent precipitation. So we actually have a lot of weather in the Southwest through the wintertime, but very little of it actually produces precipitation, which I think is a little bit disappointing, right? And I do think that we think of, well, when it's not raining here, it must be because we're under a ridge of high pressure and that's fair weather, right? But actually what ends up happening between October and April here is that we have a lot of low pressure systems move through the Southwest, but they're moisture starved and they actually can't produce any precipitation.
We actually have a lot of weather here. And I think what's interesting that aligns with this point that the storm track is actually overhead quite a bit. And actually in that paper, I'll give the title just for reference in case people want to look it up. I found this like super useful. It's in a monthly weather review, the journal Monthly Weather Review, and the title is The Climatology of Synoptic-Scale Ascent over Western North America, a Perspective on Storm Tracks. Yeah, and Mike, like you said, there's quite a bit of literature on this that I'm not all that familiar with, but you know more about. That's been long going. So there's quite a bit of this storm track nuance here. What's cool is that, like, for those people that aren't watching weather maps, geopotential height weather maps every single day, like they don't have that like running log of like what the 500 millibars are doing and the ridges and troughs are doing and how they're evolving, moving. It's funny, like, 15 minutes ago, I came back in and you were like, yeah, I was looking at the wind today. I keep looking at the wind patterns today, and I'm like, wow, I rarely do that. But even when I go out on a bike ride, I rarely do it. But you're actually looking at what's cool about what you do, and I think what is how you can appreciate that the storm track idea isn't so prominent in people's minds is because you actually have to look at like the region to see these things unfold, to see where it's coming from. And in that paper, they actually talk a little bit about the frequency of that sort of mean position, the average position of the storm track. And it's like, 8% of the time, it's over Arizona. And, so what is that, like 4 days out of the month, which sort of aligns itself with what we were talking about before. The other point of this is, okay, so we have quite a bit of weather. There's not a lot of moisture around for some of them. We get a bunch of wind instead and not a lot of rainfall. And then, so the reason for that is in part that the storm track position, it's diving from, let's say, Alaska. Let me see if I can't find that trajectory in this paper. Yeah, so it's coming basically, from the coast of British Columbia down off the coast of Washington and sort of enters into the U.S. around the border between Oregon and California, and then basically does a southeast diagonal through Tucson, more or less, and then it moves east and back up north. And so that's a pretty long fetch to get into our area. And so a lot of the moisture that might be accumulating from maybe going over the ocean is already squeezed out, but it's also coming from high latitudes, which are moisture starved to begin with, right? And so much of the moisture that we need is from the tropical region. So the fetch is an important story from this, and where it's coming from is an important story for this.
Yeah, totally. I mean, and that in the National Weather Service and the discussions, you'll often hear about some of these inland low pressure systems they're called inside sliders. I think is that right? Is that what we've talked about them in the past? I think it's kind of a baseball reference. Yeah, it's kind of a cool way of thinking about it. Is like, it's this low pressure system dropping down on an inland track, and that inland track doesn't have the ability to really pick up any moisture along the way, and whatever it brings with it is what you have to work with. The better chance of getting precipitation out of those kinds of events is if they're really cold and they have a little bit of moisture with them and they maintain that cold temperature, because that will maintain higher levels of relative humidity. But if it warms at all and loses any of that moisture, it's just going to turn into a dip in temperature, an increase in wind, and it'll kind of move its way off to the east.
So in those events that we had in December, were they fueled by subtropical moisture?
Yes. So that was a completely different ridge trough position. So the ridge was much further. We were talking about this earlier, much further off to the west in the Pacific. And so there's a broad trough in the Eastern Pacific, and that had a long fetch to subtropical moisture. And so those were the atmospheric rivers we were talking about that were hitting California, I think even earlier in the fall and then into December. And so we were able to benefit from that kind of long fetch, as well as cooler air, which is another kind of important aspect of these broad troughs to funnel the moisture into it. And those filaments of moisture in those atmospheric rivers work their way up and down the West Coast. And when they were in their southernmost track, they were able to clip most of Arizona and up into the Central Rockies.
All right, so I'm working this out in real time here. And maybe this is a little bit confusing, but the sort of average position that I was describing before is its trajectory brings weather from the northwest, which isn't necessarily conducive for, it can be, but it's not conducive for a lot of rain.
That's right.
So it's almost as if the broader patterns that don't take an average character is more important for rain generation than the average storm track position, if that makes sense.
Yeah, that's right. That's right. So you can get really subtle shifts in these ridge trough positions, not too many degrees longitude in either direction, and they can change the entire dynamic of what you'll see, right? So like today, broad ridge across the west, basically across much of the west, the trough is diving through the central Great Plains, northern Great Plains, central Great Plains. So it's dry and warm here, except we're getting some of this cold air that's squirting back towards the east as far south here. So that's largely dry. It's kind of dry everywhere. It's also very wet on the top side of the ridge, where that ridge is actually transitioning to a trough across British Columbia and basically up into Alaska right now. Think about that whole pattern shifting further to the west, puts us underneath the low pressure system now. And now maybe it's a broad cool down in air, but it's still dry. Move it even a little bit further, where it's able to, now that trough is a little bit more in the Pacific. Now it's actually has the possibility to pick up some moisture, and it turns into a wet storm for Southern California, Arizona, and New Mexico. So these little subtle shifts can really make a big difference.
Trajectory matters. This is so cool. I'm sure we lost everybody.
I totally,
including me.
At least we're having fun talking about it. But so I don't know if you noticed, but in this paper, it's kind of cool. On the difference between El Nino and La Nina is it's subtly different as far as the maximum of where the storm track shifts. And this is just to bring it all back together. But in La Nina winters, like this winter, you can often see a strong ridge of high pressure form over the eastern Pacific, which is often represented in the Pacific North America pattern. So and you see this Pacific North America pattern in its negative phase is a broad, strong trough over the East Pacific. Ridge over the East Pacific, trough over the west, and then ridge off to the east. That is strengthened and enhanced, and you'll see a higher frequency of these kind of inside slider, cold, dry trough events across the Southwest.
In what ENSO phase?
La Nina.
La Nina. Okay.
Yeah. So you see it. So it's interesting. So it's like La Nina in the Southwest is dry, but it doesn't necessarily mean that that's forced by a ridge of high pressure. Sometimes it is. Sometimes it's just a bunch of dry storms moving through the area, and it keeps temperatures cold. It's also why the temperature correlation with La Nina is a little bit messy across the Southwest as well.
So December, it wasn't historical by any means. It was a good month. But I'm just curious, were you surprised at the rainfall?
No, I wasn't surprised. I kind of went into December with this idea of like, you know what, we could have one of those December rallies emerge. And it is because you can see little subtle shifts in past La Nina events where these atmospheric rivers set up, and sometimes they'll settle into the Southwest. Again, the canonical La Nina, the long-term correlations, and we're even going to see this play out, I think, when you look at the 3-month to 6-month totals over the winters, it will be below average, but you can have these little short wet periods in there because of some of these dynamics.
Okay, well, I think that's a good segue, Mike, because I think we should review a little bit about the snowpack conditions across the West. Again, mirroring kind of where we were last podcast with the sort of drier conditions, and it had just started snowing. Our point was it had just started snowing in the mountains with that rainfall event. our point was like, it's still early on. Our expectations, like I said in the beginning, is maybe drier than average, but nothing to raise the alarms yet. And now, fast forward a month and a half, maybe halfway to the peak snow water time, and which happens around April 1st every year. I think we have a pretty good picture, maybe not a good picture, but we have a picture worth talking about of snowpack across the West. And again, it's the same sort of story. Broadly speaking, the basins across the West are hovering near average, if not above average. Like the Upper Colorado River, for example, is slightly above average at 116%. The Gunnison River Basin is at about 121%. Little Colorado in Arizona is right around 100%. California, which saw the brunt of those atmospheric rivers, the Northern Sierra is where like the Sacramento River is, about 122% of average. Central Sierra is 96. Southern Sierra is 110. It's not a bad picture. That's what I'm going to say. And I guess maybe the expectation with a La Nina event is that this would be worse than it currently is. But I'm a half full kind of person, Mike. So I think with December, we can roughly say that the worst case scenario isn't going to happen. What's your take?
I don't know. I'm trying to not be pessimistic, but I still kind of feel like it could go wrong. The rally we had in December, because I'm looking at snowpack across, the Upper Colorado. The correlation between La Nina and El Nino for the Upper Colorado is pretty close to zero. So it's definitely the correlation increases where you get drier conditions during a La Nina winter as you go further south. And if you look at snowpack like the Gila River watershed, which is down, it straddles the Arizona-New Mexico border, it's at 66% of average right now. So that's kind of holding true as far as the pattern. The broader pattern, those broader watersheds, they're right at average, they're above average. We're maybe halfway-ish, maybe a little further than halfway. And I don't know. I got a bad feeling.
Is it, you think it's going to stop snowing? Or because right now, we're right at average. And let me make a case for you about why we can rule out the worst case scenario.
I think you should do that.
All right. So I'll use as the example, I'm just going to pull from the Upper Colorado River region and make this case. So right now, we're more or less, 110% of average. If you take the rest of the year and say, okay, what's the lowest amount of accumulation that could have occurred by taking the lowest value of each year for a particular day going forward? It's like adding up the worst for every day going forward and averaging that. Okay. So what that would mean is that basically from this time on to peak around April 1, the accumulation in that region on average is, for snow water equivalent, is about 5 inches. Okay, so if you added that 5 inches to where we currently are, we'd basically be slightly above the worst case scenario. Now that's like a theoretical, that's not going to happen because that's not the worst case scenario isn't any one individual year. It's just like the worst of all of the years.
It's a composite. Yeah. Yeah.
The composite of all of the years. So I'm not saying that's a high bar, right?
It's not a high bar. I know. And it's a little bit extreme for me to be so pessimistic, at this point. And I think when we were poking around at that, if you plotted 2002 hugged a lot of that composite min. So 2002 actually contributed to, I think, a lot of those lowest values. 2002 was pretty extreme as far as its pattern, and already the snowpack in December exceeds what it was in 2002. So I think, to your point, you'd have to have something dramatically different happen for the next couple of months. And I think what that would look like would be super strong ridge of high pressure over the west, which would block incoming storm track, and also melt a bunch of that snow. So that would be another way of like eating away at the snowpack, is like it stops snowing and you start to lose snow pretty precipitously earlier than you'd expect to lose it.
Yeah, and just again, using the Upper Colorado region as an example. So right now, it's on average about 9.6 inches of snow water equivalent. And just comparing it to last year at this time, it was 6.6 inches. So it's 50% more than it was last year. So, I mean, that's just a comparison to where we were last year. And I can't remember how last year was pretty bad at this time. It was in the lower 10th percentile. So it's maybe not a great comparison, but yeah.
You know, we should point out too that, so there's an interesting thing going on this year that I don't exactly know how to play out, but, and maybe you can talk a little bit about what the streamflow forecasts look like. But so that record dry monsoon summer led to very dry fall, dry winter. I think, you know, that combination of things, remember we talk about the fall soil moisture levels being important as snowpack accumulates on it to help sort of prime the pump for good runoff and stream flow into the spring. So maybe we're in a better spot now after the really good monsoon precipitation, some fall precipitation that actually occurred in some of the upper basin, and then better soil moisture. And then the December, I mean, does that help put us in something different?
When you look at the National Resources Conservation Service, like their streamflow forecast page, it actually doesn't bear out that way. They're actually more pessimistic. So how these things work is like, it's a combination of taking what's already occurred and then forecast into the future of what could occur based on, you know, historical distributions and maybe like, you know, the most current or the next 7-day weather forecast. So what's important here is like the forecasts themselves get more accurate as history builds up. So it's more accurate now. And these are forecast projections for like the runoff season. So it's like the total runoff later on in the year. So and those runoff windows change depending on the basin, but these forecasts take that into account. So they're forecasting for basin for a particular time period that is unique, maybe not unique, but that pertains to that particular basin. So yeah, the forecast now would be more accurate for the total flow of, let's say, what would it be? April through, I think it's like April through August or April through September for some of these basins. It would be more accurate now than it was the last time we did this podcast. And it'll be more accurate in a month. But when you look at the forecast map, it's all below average across the basins that we care about here in the Southwest. From the lower Colorado River in Arizona is 43% of average. The Gila that you were mentioning is 26% of average. The Rio Grande, the upper Rio Grande is 63%. The upper Colorado River, which is what I was using as the example for snowpack, is 78%. And those are all currently above average snowpack, but below average streamflow forecast because they're thinking about the future.
Okay.
Yeah, it's they're expecting things not to, you know, based on how history has played out. They're expecting things December not to repeat itself, if you will.
So they're not based on current snowpack. They actually have a lean into the future.
Yeah, they are in part based on what's happened up until this point in the past.
Okay.
So when you look at the cone of uncertainty, like it decreases through time as you get closer to the runoff season because more of the water we already know what's in the basins.
Yeah, right.
The snowpack has already occurred and you just have less time to gain that up. So because it's forecasting for April 1st, right? It's forecasting for total runoff during the runoff period.
Got it. Okay. Got it.
Yeah. Right. Because very little is running off now from, let's say, the upper Colorado River Basin because it's let's say 80% of the water in the Colorado River comes from the snowpack, right? So we know when most of that snowpack will melt. And when you look at the peak snowpack graphs, the peak is like April 1. And then the snowpack sort of decline through time because it's melting. There's still some accumulating, right? But it's on average, it's melting more than accumulating. Yeah. So I think the point here is maybe it helped to your question, the monsoon, but we're not seeing it. And I would say that monsoon bump might have been, in terms of soil moisture, might have been marginal. Like it's probably helps, but like it's not the determinant.
Yeah, and it's probably small. I don't know if it's modeled well either. I mean, I'm out of my lane. I don't totally understand how a lot of these streamflow forecasts work, but I think maybe to your point too is that it is just about the beginning of February, and I was looking at the NOAA Colorado River Basin Forecast Center sites, and they won't issue peak flow forecasts until March. So we're kind of still in that gray area of wait and see to see how these snowpack numbers look over the next month in particular. And we'll maybe talk about the outlooks at some point here too. And they're kind of like a shrug for most of the basin over the next couple of months. So, I mean, doesn't give us a lot of, lean either way.
Yeah. I mean, the streamflow forecast, like I always get depressed looking at them. So I can't remember when they've been above average.
I can't either. I mean, and I think, that's the, part of the climate change story is just that it's a lot harder when it's warmer to generate good, efficient runoff.
Should we sprinkle in some drought? Anything you want to say about drought? I mean, I think the story is the overall drought picture in the Southwest has maybe improved slightly through the winter, which maybe goes against what we would have bet on, if you will, coming into this. Again, fueled mostly by December, which again I think is an optimistic story. We'll see how that plays out. But what's your take on drought? Anything you want to report there?
Yeah, I think just what you said too is that you saw drought improvement across a large swath of sort of the coastal West due to that precipitation in the fall and especially into December. And then you got this really interesting kind of convergence of precipitation across Arizona in particular, which was the crazy wet monsoon. And then we went into that dry spell through the fall and then had wet December. And so I think that those two things piling on top of each other have pushed a majority of Arizona into abnormally dry, which is D0. So it's kind of the precursors to official drought, but, still the Four Corners area is still in moderate to severe drought. And then New Mexico has not seen quite as much of this precipitation and is as you go further to the east there, that drought signal really kind of increases because they didn't get as much, either of the really, really wet monsoon conditions that we saw kind of centered in central Arizona, and through the fall and the winter hasn't been that wet as well.
Yeah, and the seasonal drought outlook is calling for those areas in Arizona and New Mexico that are under
abnormally dry right now.
Yeah, abnormally dry to actually develop into drought conditions. And again, that's all reading into these seasonal precipitation and temperature outlooks that are so heavily influenced by at least in my view of them, they look like they're drawn from the La Niña canonical precipitation pattern. But yeah, and so those precipitation, the 3-month precipitation outlook sort of has below average conditions for the southern tier of the U.S. with the highest likelihood at, a 50% chance, 50 to 60% chance in southern Arizona. So yippee for that. Yeah. So you were saying it was kind of like a shrug, but I feel like this is about as bullish on dry as you can get with these seasonal projections.
Okay. So the shrug is actually when you start to look at the forecast, the suite of forecast products from the Climate Prediction Center. Ben and I were chatting about this earlier, where the 6 to 10 day and the 8 to 14 are kind of that short end products, and they're probabilistic in the same way that the 3 month, the 1 month and 3 month outlooks are as well. Well, on the shorter time scales, the weather scale variability has been really challenging, and the forecasts have been really kind of going all over the place, especially kind of looking out at that 2 week window. So it'll kind of, it'll lean dry, it'll lean wet, lean dry, and then it, ends up, especially for the last 4 weeks or so, we've just ended up dry. So there's quite a bit of uncertainty, at least the current outlooks out through 2 weeks point to dry across the West again. So that we're going to be in that dry pattern. But it's interesting, the week 3-4 forecast, which puts us out through into the late part of February, for much of the Southwest is actually equal chances, right? So there's kind of if you read the discussion too, there's a bunch of signals kind of competing with each other, but a recognition of La Niña still hanging around. And then, like you're pointing out, as you go to the 1 month and the 3 month outlooks, which are issued, 1 month is issued, I think, twice a month. And then the 3 month is issued once a month. They're still kind of banking on the La Niña signal. And La Niña is still cranking away and is expected to kind of fade through the spring, but it kind of doesn't matter at this point because the atmosphere is fully engaged with the La Niña signal. It's getting jerked around by some other intra-seasonal signals like the Madden-Julian oscillation, which I think had something to do with the precipitation in December. It's weakened quite a bit, so La Niña is a little bit more in control right now. It's still, I think, a fair bet to expect drier than average conditions out through the rest of spring. Again, I'd be elated if Arizona and New Mexico got some good heavy precipitation over the next couple of months. I think it's unlikely. The upper basin, again, that La Niña correlation is quite low. So I still think that there's opportunity for it to go okay or poorly
right
a couple of months.
Yeah, let me clean something up because I was looking at the 1 month outlook, and I think I said that the percentages for the 3 month outlook. So
they're pretty close to each other, though. Yeah.
They are, but the 50 to 60% chance sort of shifts in the 3 month from southern Arizona, where it was in the 1 month, to basically to southern New Mexico. So and this could be that it's really interesting where Arizona and New Mexico can sometimes have different winters, even though we're next door to each other. Right now, that dry signal has been hanging out in New Mexico and into Texas. Maybe that is going to be more persistent through the rest of the spring. Yeah, and the 3 month seasonal outlook does paint Colorado with a higher likelihood of drier than average. So that goes back to our snowpack and streamflow forecast, if that plays out. But yeah, I mean, it's not only drawing from ENSO. I sort of made it out to be that these forecasts they're not just like looking at one metric, and there are other things going on. So yeah, even if there isn't like a high La Nina El Nino correlation with precipitation in Colorado, that there's other things that they're looking at. But these are what they are, and there's a lot of chances for the opposite thing to happen. So
for sure, right? I mean, this is the fun game that's kind of emerged over the last decade, is to like kind of think about, and I've made these up, like Fabulous February and Miracle March or Magnificent March or Awesome April. I don't even know. Like, we've had in the past these crazy rallies that are late spring that clobber the upper basin in particular, and they become really beneficial for boosting stream flows. But they're like subseasonal variability that we just can't anticipate. So right now, it just seems like the most likely outcome is based on the historical statistics and trends.
I'm getting the sense that when we come back, let's say we weren't doing this for 2 months.
Yeah.
And we're going to do it next month, but let's just say, mid-March, if we did this podcast, or when we do this podcast, if I were to say, okay, Mike, are you surprised that we're it's been really dry this winter, your answer would be like, no, this is kind of what I expected. Like I'm kind of getting this, in other words, I'm kind of getting the sense that you're sort of leaning toward a drier winter.
I think I'm so indoctrinated into the cult of Enso that I can't break out of it, man.
Can't break out of it.
No. I mean, it's not a cult. I mean, it's science.
It's the best guess.
It's the best guess.
Maybe guess isn't the right word. This is a lot like fantasy football for people that play, fantasy sports. It's like, well, you're using a whole bunch of information to try to make an estimate about how, or maybe just like the better analogy is just like betting on the game. So like a couple of weeks ago, it was Buffalo versus New England in the first playoff round. And it was like super cold conditions. And like people were trying to like, guess the outcome, obviously, because they're betting on it. And like, they're drawing on a whole bunch of different information. It's like, okay, like historically, in sub-zero weather, like scores, the average score is like, 17-13. And that matters. And like, it's all that information that you're trying to use to hedge your bets. Of course, I think Buffalo stomped them. Like they scored like 40 plus points and that. So it went the other way. But if they had played 10 times, maybe those games would have, been, 17-13, closer to 17-13 than what the final score was. And I'm forgetting what the final score, but it was like probably like 41-17 or something like that. So anyway, it's a lot like that.
It's a good analogy that, it doesn't mean it's impossible, but it's like, if you have that information in the past is like that past performance, you use it as a prediction, even though, your investment advisor tells you past performance does not indicate future outcomes. I'm
with you. I think if the optimist in me, the Friday Zack is.
Did I just bring down Friday Zack?
Yeah, I knew
kind of bad now.
No, you have the Monday mic, man.
I do it.
You're the Monday mic.
I do have Monday mic on. I know that's not good.
All right. Well, cool. I mean, couple more months, like we'll be preluding the monsoon. So
I know. Yeah.
I just had to mention the monsoon again. So
can you believe it? It's going to come back. I'm excited.
All right. Well, thanks everybody. Hope you had a great start to your 2022. And thanks as always for listening to us. And hope there's something valuable in these conversations. We like to do them. So thank you all. We'll see you soon. Thanks, Mike. Zach, can you hold on 1 second? You bet.
I got to go let my son in the house because he just got home from school.
Well, I hope Ben keeps that in. This is real time. Figure 12. That is really interesting podcast language right there.